Hello, my name is Mуцький Mihайло and I'm the student of Politechnic Lyceum of НТУУ КПІ in Kyiv. And the title of my work is Improving the Technology of Obtaining Porous Aluminium. Topicality. The creation of materials that have a complex of unique properties and combine high mechanical characteristics and low specific weight becomes necessary in modern high-tech industries of energy, aviation, rocket engineering, mechanical engineering, and medicine. The use of materials with an adjustable porous structure allows you to solve the problem of reducing the specific weight while maintaining the parameters of strength and plasticity. At the same time, the main problem of manufacturing such materials is the difficulty of ensuring the required dimensions and uniform arrangement of pores in the structure of the material, which requires the search for technological solutions that will ensure the production of porous materials with specified properties. Properties of porous aluminium. So for the first, it's low specific weight and high specific strength. It's also corrosion resistance and high terminal conductivity, high electrical conductivity, and environmental friendliness. It's also filtration of gases and liquids, heat exchange, sound absorption, pneumatic transport, creation of energy-absorbing elements, and protection of sensor and gas analyzers from mechanical impact. Areas of application of porous aluminium. The main areas of application of porous aluminium is lightweight structural parts. It's also thermoforming of polystyrene products, evaporation of liquids, aeration of liquids, vacuum tables, decoration, and design. To obtain porous aluminium, modern production uses several different methods, but unfortunately each of them has some disadvantages: high energy consumption, complex equipment, or considerable financial costs. Therefore, in our opinion, a deeper study of the technological parameters of infiltration which affect the formation of the structure, porosity, and mechanical properties of porous aluminium is expedient. The practical part. A combination of casting methods with the use of pore-forming materials was used for the production of an aluminium porous system. Melting and heating of aluminium is carried out to temperature of 750 to 800 degrees Celsius in resistance furnace. Sodium chloride as a foaming agent. This material was sodium chloride. For this, the size of particles from 0.6 to 1 millimeter was used. From the point of view of physical properties, the melting temperature of sodium chloride is 801 degrees Celsius, is important for the production of porous material. Before pouring the aluminium melt into the preheated mold, salt was subjected to heat treatment to connect the gas cells in the porous material. Per aluminium powder. Aluminium is melted and heated to a temperature of 750 to 800 degrees Celsius in a resistance furnace. The melting temperature of aluminium is 660.32 degrees Celsius. But to obtain the appropriate fluidity, you need to heat the metal approximately 100 or 150 degrees Celsius more. So here's the scheme of aluminum impregation of salt. You can see here body, holder, fitting, lower cover, metal receiver, membrane, pour former, hose, and vacuum pump. The prepared samples were immersed in boiling distilled water, where they remained for 1 hour. This procedure dissolved the sodium chloride particles. After the dissolution process, the obtained samples were left in a dryer for 1 hour to remove the remains of distilled water. The interconnection of open cells in the structure of the obtained porous aluminum was evaluated using a metallographic microscope Neptune 21. The image was displayed on the computer monitor. Here you can see our photos. On these photos you can see that we got open pore structure. Study of mechanical behavior of porous aluminum under compression conditions. The tests were carried out on certified universal machine ceramic test with a capacity of up to 10 tons according to ISO, which is used for porous samples. So here you can see the graph, and on this graph you can see the yield straight, the straight limit, and the deformation to failure. Compression tests were performed on prismatic samples with a ratio of height to cross-sectional area of 1.5. So here's the table. Here we determined the characteristics of the limit of proportionality, the yield straight characteristic, stress at the inflection point, and plastic deformation for each of our samples. So conclusions. It's shown that the size of the filler doesn't affect the total porosity of samples, which is 60–65%. Crystal salts require preliminary heat treatment to remove excess air and moisture. Size according to the smaller size of the original particles of the filler, which is due to the partial destruction of the filler during the impregnation process. The mechanical properties of the samples correlate with the theoretical understanding of mechanical behavior under compression, and developed technology is promising for the industrial production of porous aluminum. Thank you for your attention.